Hi there, my name is Ogodino Uche Jude. Welcome to today's online class. Our further math topic I'm going to treat today is coordinate geometry. So let's go through our lesson objective. So by the end of the lesson, the student should be able to determine the condition for parallelism and perpendicularity, determine the equation of a line in different form. So the first one is angle between two lines. So the formula for angle between two lines is given as tan alpha is equal to the absolute value of m2 minus m1 all over 1 plus m2 m1. So example 1. Find the angle between the following pairs of lines AB and BQ. So that's the first thing we are going to do with. Now, the first example, find the angles between the following pairs of lines AB and PQ. So pick just one. We pick the first one, then you can try the second one yourself. 3, 1, B, 4, 3, P, 4, and 6. And Q is 5, 8. So let's go through this. So example, this one, A. So if you're going to solve this now, our solution is, we write out the coordinates A, 3, 1, B, 4, and 3. So if you want to find the angle between this pair of points, we need to get the gradient. So how do you get the gradient? This place is your x1. This is your y1. This is your x2, y2. I repeat, x1, y1, x2, y2, the same for any coordinate given to you. When two coordinates are given to you, and we have each point on the coordinate 3, 1, 4, 3, 4, 6, and so on and so forth, what you do now is the first one is x1, y1, x2, y2. If you want to start with this is x1, y1, x2, y2. So our formula for gradient m is given as y2 minus y1 all over x2 minus x1. So we get our first gradient, m1. So what's the first gradient? What's our y2 there? Our y2 is 3. y2, 3. Minus, there's minus in the formula, y1 is 1. So this formula, this is our gradient all over, then x2 is what? 4. Minus x1 is what? 3. So m1 will give me 3 minus 1. 2 over 4 minus 3 is 1. So my m1 is equal to 2. That is for m1. So I'm going to look for, please go through this quickly. M equal to y2 minus y1 all over x2 minus s1. That is how to get the gradient. But we are going to get two gradient. This is the first gradient for AB. So gradient AB, gradient AB, gradient AB is equal to this. All right. So I'm going to get gradient of the second line given to me. So if I'm going to get that gradient, that should give me the coordinates for P and Q. P is 4, 6, and Q is 5 and 8. Still x1, this is your x1, y1, x2, y2. So gradient m2 will give me what? y2 minus y1 all over x2 minus x1. So my m2 will give me, what's y2 there? 8 minus y1 is what? 6 all over x2 is what? 5 minus 4. So my M2 will give me 8 minus 6, 2 over 1. M2 is equal to what? 2. So this is what I'm going to get as my M2. So recall that M1 is equal to 2. M2 is equal to what? 2. So these lines are parallel lines. When we continue, you understand. So parallel lines, no angle between them, but let's just apply the formula. So that will give us tan theta, or alpha as you have in your note, is equal to absolute value of M2 minus M1 all over 1 plus M1 M2. So tan alpha will give us what's M2? 2 minus 2 all over 1 plus 2 times 2. So tan alpha, or tan theta, because I'm using theta, but in your notes I use alpha. Whatsoever the textbook or whatsoever you're using want to use, you just follow suit. So this will give me 0 over 1 plus 4, which is 0 over 5. Tan alpha, tan theta is equal to 0. So wiping this other part off, please make sure when you're watching this video or any video given to you, you pause and understand the step. So that gives me theta will now be tan inverse of 0. Theta will give me 0. So no angle between this one, 0 degree, there's no angle. But the most important thing is using the formula. So let's go to another example that we actually have a value. So this is the solution. I will go 0. Let's see this example 2. Find the acute angles between 4y plus 3x equal to 2 and x minus 2y equal to 3. So I'll write that question down. Example 2. Find the acute angle between 4y plus 3x equal to 2 and x minus 2y equal to 3. So our solution. So in this particular question, we are going to use what we call gradient intercept form. So this is our gradient intercept form formula is y equal to mx plus c. So you compare whatsoever has been given to you. Let's try the first one. Y, or 4y plus 3x is equal to 2. In this particular equation, y is made the subject of formula. So any question given given to you in this format, make sure that y is the subject of the formula. So 4y is equal to what? If you go over to this side, 2 minus 3x, this moving to this part. So this gives us 4y is equal to, make this one come first because of mx, minus 3x plus 2. So you are rearranging. There's plus here. This one comes to this side. This one goes to the other side. But if you look at the formula, nothing attached to the formula, meaning you need to divide by 4. Divide both side by 4. So y will now give me minus 3x plus 2 over 4. Now separating, y will now give me minus 3x over 4 plus this one over this, plus 2 over 4. So y will now give me minus 3 over 4x plus 2 here 1, 2 here 2, 1 over 2. So this is the most important thing I need in this particular question. Anytime you see M in coordinate geometry, M represents gradient, and it's the gradient that we are actually looking for or want to extract. So let's extract the gradient and call that first one M1. So M1 is equal to what? Minus 3 over 4. So how do we get M2? We follow the same procedure or steps. So this is x, the second one, I'm dealing with the second one now, x minus 2y is equal to 3. We want to make it y equal to mx plus c. So which one should be the subject of the formula? X is equal to, take this one to the other side, that is what? 3 plus 2y, right? So if I interchange, this goes to this side, x minus 3 is equal to 2y. I can equally start with this. So let's just rearrange. 2y is equal to x minus 3. From what I said earlier, we need to make y stand alone. So remove this coefficient, divide both sides by 2. So y is equal to x over 2 minus 3 over 2. Of course, there's an invisible one here, so that is half. So y is equal to half x minus 3 over 2. So half x minus 3 over 2, if we compare with y equal to mx plus c, your m2 will now be what? Half. So my m2 is half. So m2 is equal to half. But we are actually looking for the angle between those two lines, and we've gotten the gradients of the line. So what do? You apply the formula. The formula states that let me use alpha this time, is equal to absolute value of m2 minus m1 all over 1 plus m1 and 2. So tan alpha will give me, what is my m2 half? Absolute value of half minus 3 over 4 all over 1 plus half times minus 3 over 4. So that should give us what? Let me write the value of m1 and m2 somewhere. m1 is equal to minus 3 over 4. m2 is equal to what? Half. So cleaning this part off, that will now give me tan alpha is equal to half plus 3 over 4 all over 1 minus, this one will give me 3 over what? 8. Yes, 1 minus 3 over 8. So if we look for the LCM of both, what's the XCM? 4. 2 goes in 4, 2, plus 4 in 4, 1. 1 times this, 3. So the next XCM, let's make this 1 over 1. This is 8. So this gives me 1 in 8, 8 minus 3. So this will give me 5 over 4 divided by, what was this one again? 3 divided by 5 over 8. So what do you do now? The next thing we're going to do now is we say tan alpha is equal to 5 over 4. Let's go through it. 2 here, 2, 4. Okay, 5 over 4 times 8 over 5. This cancel this. 4 here, 1, 4 here, 2. So tan alpha is equal to 2. Alpha is equal to tan arc 2. So tan raised to power. So you press the second function tan 2 and you get your answer. So that is actually how to solve this. Okay, I suppose you know how to get gradient. So I'll just go through what I've just done when the board was a bit smaller. So what we actually do now is, or what you are going to do is, you get M1 with y equal to mx plus c. Or let me take it again. Let's start all over again. Sorry for not noticing that the board was a bit smaller. Okay, this first one, y equal to mx plus c. So this one is what? 4y plus 3x is equal to what? 2. So 4y will now give me minus 3x plus 2. This one will go over to this side, and that is that for that. So our y will give us minus 3x plus 2 divided by 4. So I'll separate y equal to minus 3 over 4x plus 2 over 4. So y will give me minus 3 over 4x plus half. So that's how we go m1 equal to what? Half. M1 is what? Half. Then let's get our M2. So if we are going to get M2, M2 will be giving us what? We use y equal to mx plus c. What's the next one? X minus 2y equal to 3. If you take this one to this side, that gives us x, bring this one here, minus 3 is equal to 2. y. So 2y is equal to what? X minus 3. Just changing the position. Divide both sides by 2. X minus 3 over 2. This cancel this. Y will now give me separate x over 2 minus 3 over 2. There's an invisible one here. So y is equal to mx plus c. Our m2, that's the second gradient, is what? Is half. So our m2 is half. Our m1 should not be half again. So go over our m1 once again. Let's get our m1. 4y plus 3x is equal to 2. 4y is equal to minus 3x plus 2. Y is equal to minus 3 over 4x plus half. Okay, this is the one I'm supposed to pick, not half. So our m1 is minus 3 over 4. Our m1 minus 3 over 4. m2 is half. So what do we do now? We are going to apply it to the formula because all this one we are just doing, we got the gradient of this first line, and that is m1 minus 3 over 4. We got the gradient of the second line, which is m2 equal to half. So we are going to apply to the formula to get angles between two lines. Then alpha will now give us absolute value of m2 minus m1 all over 1 plus m1 m2. So this implies that our m2, we got m2 as what? Half. So tan alpha is equal to, yep, half minus is in the formula minus 3 over 4 all over 1 plus half times minus 3 over 4. Okay, so tan alpha will now give us half plus 3 over 4 all over 1 minus times plus is minus 3 over 8. So this means that we are going to do what? Tan alpha is equal to, let's look for the LCM of these two. That's 4. So 2 goes in 4, 2. 2 times 1, 2 plus 3 all over 1 minus 3 over 8. That is 5 over 8. So tan alpha, you can use the LCM to get this. So 8 minus 3 give you 5 over 8. So this will give us 5 over 4 divided by 5 over 8. And so tan alpha will now give us 5 over 4 times 8 over 5. So tan alpha is equal to 2. Alpha is equal to tan arc 2. So use your calculator to get tan inverse of 2 and you get the answer. So let's go back to our discussion. So condition for parallelism and perpendicularity of straight line. So if you're asked to get or check for the parallelism or perpendicularity of straight lines, the first condition is if m1 is equal to m2, that's gradient of the first one is equal to m2, then they are parallel. If the gradient of the first one, m1, multiplied by m2 gives you minus 1, then they are perpendicular. So let's go through this question. So determine, example 3, determine if AB is perpendicular to PQ in each of the following. A, the coordinates are, for the first one, A, 3, 1, B, 4, 3, P, 4, 6, Q, 5, and 8. Then B, 5 minus 1, B, 3, 2, P, 2, 4, and Q, 5, 6. So let's solve it. Now, the first one, A. Let's get the gradient of AB. Gradient of AB, we call it M1, is equal to, formula for gradient is y2 minus y1, x2 minus x1. So remember what I said, or recall, this is x1, y1 for AB, that's for these two, x1, y1, x2, y2. So we have made it easier like that. This is your y2. Y2 is 3 minus y1 is what, 2 over x2 is what, 4 minus what is your x1, 3. So M1 is equal to 1 over 3 minus 1, 2. Sorry, this is 1. 3 minus 1, 2. Then 4 minus 1 this. So M1 will now give me 2. So that's gradient of AB. So pause your video and watch very well because I don't have much space. I'm going to clean this again to get our M2. M1 is what? 2. So let's get M2. So solve for M2. M2 will fall between the line PQ. So gradient of PQ is what? M2. The same Y2 minus Y1, X2 minus X1. So M2 will give me, what's my Y2? So this is X1, Y1, X2, Y2. So what's my Y2? 8 minus 6. That's Y1. The X2 is 5 minus X1 is what? 4. So M2 is equal to what? 2 over 1. So M2 is equal to 2. So if you look at the answer now, our M1 is 2, S2 is 2. So M1 is equal to 2, M2 is equal to 2. They are now parallel. They are parallel. They are parallel because they have the same gradient. They have the same gradient, and their gradient is 2. So we solve the first one. The first one is parallel. So let's solve the next one. And the next one should be perpendicular. So how do we know whether they are perpendicular? This is x1. So B, gradient of AB, M1 is equal to y2 minus y1, x2 minus x1. So this is my x1, y1, x2, y2. So M1 will give me, what is my y2? 2 minus, what is my y1? Minus 1 all over, what is my x2? 3 minus, what is my x1? 5. So M1 will now give me 2 plus 1 over minus 2. So M1 is 3 over minus 2. 3 over minus 2 will now give us what? Minus 3 over 2. So my M1 is minus 3 over 2. M1 minus 3 over 2. So to get M2, that's gradient of PQ. Gradient of PQ is equal to what? M2, Y2 minus Y1, X2 minus X1. So M2 will now give me, this is X1, Y1, as usual, X2, Y2. So what is my Y2? 6 minus, what is my Y1? 4 over X2 is what? 5 minus X1 is what? 2. X1 is 2. So that will give me 6 minus 4, 2 over 3. So my M2 is 2 over 3. So that's M2. M2 is what? 2 over 3. So let's multiply M1 times M2 to see whether we have minus 1. This is the condition for perpendicularity. That means if the lines are perpendicular, if you multiply the gradient, you're going to get minus 1. So M1 is what? Minus 3 over 2 times 2 over 3. This cancels this. 1, 1, 1, 1. So we're going to get minus 1. And since we got minus 1, the first one is parallel, the second one is what? Perpendicular. Okay? Okay, the next topic or subtopic is the gradient and 1 point form. Gradient and 1 point form. So we'll just go straight into an example. Gradient and 1 point form. So example, what is that? Example 4. So let's find the equation of a straight line of slope 2 if it passes through the point 3 and minus 2. So solution. The formula for this is what? Y minus y1 is equal to m into x minus x1. So anytime you are given 1 point and the slope or gradient. So when they say slope, they're actually talking of what? Gradient. So moving to the bigger board. Now let's proceed. Okay, our slope m was given to us as 2, which is the gradient. Now the point that was given to us is what? 3 and minus 2. So this is my what? X1, this is my Y1. So my formula is Y minus Y1, M into X minus X1. So just impute in the formula. Y stands alone. You were not given Y, but you are given Y1. Y minus minus 2 is equal to slope was given to you as 2 into X minus X1. X1 is minus 2, or X1 is 3 rather. So X1 is 3. So Y plus, minus times minus is plus, 2 times S, 2X minus 2 times 3, 6. So if you move everything towards to this side, Y plus 2 minus 2X plus 6 is equal to 0. So Y minus 2X plus 2 plus 6 is 8 equal to 0. So this is actually the equation. Or you can leave it, they usually leave the answer like this in options if it's objective. Or if you are solving, you can decide to leave it anyhow. Another way of keeping the answer or solving or showing your answer, that's right. So another way of showing your answer is what? In the gradient intercept form. So y we stand alone. If you are going to do that, that means you are going to say y is equal to, move this one to the other side, 2x, move this one to the other side, minus 8. So these are the two ways your answers can be shown. Answer. It's either you leave it like this or like this. If it's objective, then solve for whatever was given to you. But if you are solving it on your own in theory, you can leave it like this. And that is that for that. Let's go to the final one. Okay, gradient and 2-point form. The next one is gradient and 2-point form. So, example 5. Gradient and 2-point form. Okay, I've said it already. Example 5. Let's get the question. Find the equation of a straight line which passes through the point P is equal to 2 minus 3 and minus 4 and 2. So solution. So the formula for this is y minus y1 all over x minus x1 is equal to y2 minus y1 all over x2 minus x1. So if you are going to solve this now, mind you, gradient was not given to you. So this is what you are going to use to solve. If you are going to use this one to solve, 2 minus 3 and minus 4 and 2. Now you might want to ask, what's the difference between this first question and the second one? The first question, only 1 point was given to you and gradient. Now 2 points has been given to you and you can get gradient from 2 points. This part is your gradient. Y2 minus Y1, X2 minus X1 is actually your gradient. So sometimes you can solve for gradient, then say this formula equal to M, or you just use it directly. So this is X1, Y1 as usual, X2, Y2. So Y minus, what is Y1 here? Minus 3 all over X minus, what is X1? 2 equal to, now what is Y2? 2, there's minus in your formula, then Y1 is minus 3 over, then X2 is what? Minus 4, minus is in your formula, then X1 is what? 2. So that gives us Y plus 3 over X minus 2 equal to, okay, let's go through it again to avoid mistakes. Y minus 3, that's your Y1, X minus 2, so this part is correct. Then Y2 is 2 minus 3 all over X2 is minus 4 minus 2. So we are right. So 2 plus 3 all over minus 6. So this gives us Y plus 3 over X minus 2 equal to 5 over minus 6. So cross multiply. So if I cross multiply now, that will give me what? Minus 6 into Y plus 3 is equal to 5 into X minus 2. So minus 6Y minus 18 is equal to 5X minus 10. So bringing everything towards the side, minus 6Y minus 18 minus 5x plus 10 equal to 0. So if you rearrange very well, or let's multiply everything by minus 1. So multiply it by minus 1, or assume that you are moving everything to this side. That gives you 0 is equal to, let's not assume, let's move to this side, 6y plus 18 plus 5x minus 10. So 6y plus 18 plus 5x minus 10 equal to 0. Arranging it very well. Let's start with 5x. 5x plus 6y. 18 minus 10 will give us plus 8 equal to 0. This is our answer. You can decide to put it in gradient one intercept form by saying 6y. Okay, let me do it. 6y is equal to minus 5x minus 8. So y will now give me minus 5x over 6 minus 8 over 6. This is another way of putting your answer, but this is my favorite way of putting of placing your answer. So with that, that is the conclusion of this class. So that is the end of the class. So folks, thank you for tuning in again. And I hope you understood everything I've tried to explain. Just keep practicing and you become perfect. So until we meet again in our next online further mathematics class, I still remain your blessed Mr. Jude Ogodino.